electrolysis of acidulated water. And how are we going to learn this? By simply using Hofmann voltameter. What is Hofmann voltameter? It's exactly what you are looking at on the board. So let's begin. A Hofmann voltameter is a device that can be used to study the electrolysis of acidulated water. In this case, the electrolytes happens to be water, but there is something attached to it. It's going to be acidulated or acidified, so to say. So take notes. We are going to use water, but we are going to make it acidified or make it acidic by adding some drops of acid into the system, right? Now, that's the first thing. In fact, let's just look at the structure of what a Hofmann voltameter is all about. This is a funnel. You can see there. There are two calibrated tubes here containing platinum electrodes, platinum cathode at this point, and then platinum anode at this point. The tubes are calibrated, and then the substance inside is water. It's water for now. Okay, understand that? There is a small connection. Okay, we have here battery that will be used or that will power the entire system. And I will tell you how it works. It's very simple. What happens here is that when the taps are closed and the switch is put on or turned on, current begins to flow. But before that, we need to understand that we need to make this water acidified so that it becomes the process of going through electrolysis of acidulated water. So we need to make the water acidified. How do we make the water acidified? By adding some drops, a few drops of acid, maybe tetraoxosulfate 6 acid or hydrochloric acid. But in this case, we are going to make use of tetraoxosulfate 6 acid. That is it. So through the funnel, we add few drops of acid to make the water acidified. That's the first thing. Once that is done, the next thing is to ensure that the taps are closed, and then the switch is put on or switched on to allow current to flow into the system. Once that happens, we have begun electrolysis of acidulated water. Before I continue with my remaining explanation, don't forget to subscribe. Give some thumbs up. Share with your friends, students, and networks. And then put on the bell button for constant notification. Thank you so much. Let's get back to it. So what happens is that when we have certified this condition that I just mentioned, it means current now flows. Current now flows by turning on the switch. Once the switch is turned on, current flows into the system at a steady rate. Once the current is maintained steadiness, it will go to a point, steam will begin to be generated on this empty space. Steam will generate at the same time. Bubbles will generate, or we call it bubbles at the same time, or we can call it steam. Steam will be generated at this point. The steam being generated at this point is happening above the platinum anode, and it is referred to as what? Oxygen, because it's a sort of gas. That is why it appears in steam form or bubble form. That's this. Then the one, look at the column here. Look at the one being generated above the platinum cathode is referred to as hydrogen gas. This simply means above the anode, oxygen gas is collected. Above the cathode, hydrogen gas is also collected, respectively. That's what it means. But they do so according to observation to a certain ratio. If you check very well, if you observe, you'll see that from here to here it's a kind of 1 cm. And then from there to this point represents some kind of 2 cm or 2 millimeter, depending on the unit of calibration of the two tubes. So if that happens, oxygen is being collected at 1 cm. Hydrogen is collected at 2 cm. That means the ratio of oxygen to hydrogen when using Hofmann voltameter to study the electrolysis of acidulated water is 1 to 2. Take notes in case something like this can come out in exam. What is the ratio of electrolysis of acidulated water when oxygen and hydrogen are generated? So you will have options A, B, C, D, E, F, so to say. Remember, I said it is 1:1 to 2. Take notes. Okay, if we have understood that, that's what happens. And it's as simple as that. When you know this, any question that will come out from here will be very, very easy to answer. That's the first thing. The second aspect, as these things continue to happen, as current continue to flow through the whole process, and there are reactions between the water and the sulfuric acid added, we begin to understand that there are some ion exchange. Ion dynamics take place. And if, first of all, we look at water here, what we're going to have here is simply when current passes, the water splits or dissociates. Either you use the word splits or dissociates. The molecules, the ions, the particles of the water or molecules of the water dissociates into ions because the passage of current through the water has energized the water with some amount of charges. So it dissociates into hydrogen ions, all right, and then hydroxyl ions. Look at it. That's what happens at this point. If we understand this, it's okay. Then the next thing, as current continues, because a few drops of acid, also sulfate acid has been added. The dissociation here, we take this format. Because we have this, we're going to have 2 hydrogen ions, all right? And then sulfate ions. That is it. That's what we're going to have here. Because of dissociation as a result of passage of currents through the system, as you can see. And about this, the combination of this, because what this means is that the ions, the positive ions are the what? Anode. The positive, I'm explaining this, the positive ions from the anode now drift towards the cathode, of course, because positive, negative attracts. Positive, negative attracts. The cathode has negative charge and therefore produces negative ions. The anode has positive charge and therefore produces positive ions. When these are discharged, there is a drift from the anode to the cathode. And that is what happens here. When that happens, we form hydrogen gas, H2. Take notes. And then what happens here? Very simple. We are going to have oxygen, okay? Oxygen gas plus 2 molecules of water, 2 molecules of water, and then we're going to have 4 molecules of electrons, or atoms of electrons. Look at it. That's what this will yield to. If we have understood this, and we can apply any of them when it has to do with the electrolysis of acidulated water, that means we have come a long way. Okay, so that is what it means. I want to stop at this point. Then thank you so much for your patience and watching up to this moment. You may have subscribed, I know. Give me some thumbs up. And at the same time, share to your friends, networks, and students. Don't forget to put on the bell button for constant notification. I am signing out at this moment to prepare for the next class. See you in my next class. I'll be fixing it there or somewhere there. See you.